Hi everyone, I'm Whit Roy. In this lesson, we'll explore the main calculation topics that may appear in EWRB Electrical Inspector exam. This lesson is divided into three parts. Part 1, all types of common calculations. Part 2, maximum demand. Part 3, voltage drop. Let's begin. The first formula is about current. If you know the power and voltage, divide to find the current. In three-phase systems, don't forget the square root of 3 and the power factor. It's one of the most common questions in the inspector exam. Transformers limit fault current based on impedance. Divide the kVA by the percentage impedance to get fault VA, then divide by square root of 3 times voltage to find the fault current. Inspectors use this to check switchboard and circuit breaker ratings. When a fault occurs, a large current flows through the fault loop. We use Ohm's law, voltage divided by impedance. If the current is high enough, the protective device will trip quickly, ensuring safety. We find the synchronous speed and slip. Slip shows how much slower the rotor turns. A small slip means the motor runs efficiently. Once you know the current, look up the cable size in the standard tables. Choose a size that safely carries current and keeps the voltage drop low. Always round up to the next standard size. Fuse discrimination means smaller fuses should blow first. The 20 ampere fuse must clear the fault before the 50 ampere fuse starts. This keeps faults isolated without cutting power to the whole board. Some circuits must disconnect very quickly under a fault. Portable and socket outlet circuits use 0.4 seconds. Larger fixed equipment can allow 5 seconds. Inspectors must check that the protection device meets this requirement. We test that the earth loop impedance is low enough for safety. It ensures the circuit trips quickly and meets AS/NZS 3000 rules. Maximum demand represents the highest expected load at one time. We divide total power by voltage and power factor using square root of 3 for three-phase systems. Appendix C in AS/NZS 3000 shows diversity factors that can reduce the total slightly. Diversity allows smaller mains and switchgear sizes without compromising safety. We apply different factors depending on the load type. This gives a realistic current value. Not every device runs at once. Voltage drop affects equipment performance. We calculate it from cable resistance values in AS/NZS 3008. If total drop from mains to final circuit stays below 5%, it complies with AS/NZS 3000 Clause 3, 6.2. Each cable section causes some drop. We add them together to find the total. If the total remains within 5% of supply voltage, the design passes inspection. Sometimes we start with a voltage drop limit and solve backward for the required cable resistance. This tells us the smallest conductor size that meets both current and voltage drop limits. We've now covered every calculation you'll meet in the electrical inspector exam. Always write the formula first, substitute values clearly, and include units. These simple steps guarantee you full marks.